Hey, sixth graders. So today we're thinking about distance on the coordinate plane. So if we're graphing points, how far away are they from each other? So we're going to have to kind of bounce back and forth between this table and a graph to make it all make sense. So just stick with me, folks. So in this table, it's identifying for us which line segment we're looking at. Then we need to identify the endpoints. So in this case, it's going to be point A and point B. We know that because we're looking at line segment AB. The distance between these 2 points, and then we're going to use a mathematical proof to prove that we're right. So I don't need to shift the window for us to see point AB because it's right here. So let's take a look. What I do need to shift the window for, though, is for us to identify exactly what points we're looking at. So let's move up for just a sec. Aha. So here we are, right here is the origin, and I know that you all know that the coordinate location of the origin is always 0, 0. So point A, right there. So let's see, we do the x coordinates first, so 1, 2. So 2, and then y coordinates are 1, 2, 3, 4, 5, 6, 7, 8. So we know point A we can find at -2, 8. -2 because I had to move left from 0 from the origin. All right, let's check out point B. So point B, all the way over here in the corner. So let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to the right, so this is a positive 9, and we're going up, so our y coordinate will be positive as well. 1, 2, 3, 4, 5, 6, 7, 8. So we're at 9, 8 for our point. Now here's what I want to point out, and this is really important for the rest of today. They have the same y coordinate. They're both at 8 because this is a horizontal line. So they're both going to have a y coordinate 8. They're both 8 units above the x-axis. So when you see 2 points that have the same y coordinate, you know that they create a horizontal line. Now, what's the distance? Well, the distance, since they're on the same y coordinate, we're worried about these two. So what's the different distance from -2 to 9? Well, let's go down here and just count. So we're starting at A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The distance from point A to point B is 11 units. For this case, we'll just say 11. Now, how do we prove it? Well, the distance from 9 to -2. So we would say 9 minus a -2 equals 11. And you see what I did there with the parentheses? I have to do that because I've kind of got a subtraction and a negative sign. And if I don't put the parentheses in there, that would just look confusing. So let's try another one. So now we're looking at line BC. So here's line BC right there on our coordinate plane. And point C is right here. So that means that's where the line segment stops. So what's the location of point B? Well, we already know that. We know it's 9, 8 from earlier. And then how about C? Well, let's start at the origin. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then up 2. So the position of point C is 9, 2. And the distance from each other, well, let's start at C and then count 1, 2, 3, 4, 5, 6. Can we prove it? Well, 8 minus 2 is 6. And just a reminder, I got those numbers from looking at the coordinates that don't match, because that's what I had to do to figure out the distance. But check it out. This time, they have a matching x coordinate. They're both 9 away from the y-axis. So all vertical lines have a matching x coordinate. Let's keep going. So now we've got line CD. Can we find that? Oh, here we go. So another vertical line. So we're going to see if this one also has matching x coordinates. So we already know the location of point C. We know that it's 9, 2. So now let's just check out D. So D is below the x-axis, so we know it's going to have a negative coordinate. So the first coordinates, we're going to start at the origin and count 1, 2, 3, 4, 5, 6, 7, 8, 9. So positive 9, and then negative 1, 2, 3, 4, 5. So 9, negative 5. And the distance there is 7. And how do we prove it? Because negative 5 minus 2 is a negative 7. And it's okay that our answer came out negative, because if you think about it, look, we got C, we're going down. So you could say that, yeah, we're at negative 7. And we're sticking with subtraction here because when we're asking for the distance, that's kind of a different way of asking for the difference. Well, how many units are the difference between negative 2 and 9? That's why you're seeing so much subtraction while we're trying to prove. Let's check out line segment BD. So B all the way through here, totally ignoring point C. So this time we at least already know both coordinates, so we know B is 9, 8, and D is also 9, negative 5. And so the distance there is, we could say 13, or we could say negative 13, since we'll say 13 though, because I mean maybe we could be moving up and going from D to B. So we're not going to stress our positive and negatives too much today. Later on that's going to be more important, but right now we're just working on the distance. And then how do we prove it? Well, 8 minus negative 5 just so happens to equal 13. All right, how about DE? So let's find out. We got point D going horizontally to point E. So we already know D's at 9, negative 5, and let's figure out E. Well, E's down here, so let's see, 1, 2, but then we're moving left, so that's a negative 2, and then also a negative 5, which gives us a distance from 9 all the way to negative 2 of 11. And how do we prove it? 9 minus negative 2. Y just so happens to equal 11. So let's check out our next line segment, EF, which is the short little dude all the way down here. So we'll fill in the point for E, because we already know that. We already know that's negative 2, negative 5. And I bet if you're noticing the pattern, we know that F's going to share a coordinate. So F, oh, also, boom, negative 2 away from the y-axis. But then negative 1, 2. So negative 2, negative 2. So that moved us a distance of 3. And here we're going to prove it because negative 5 minus negative 2 equals negative 3, which is still a distance of 3, which is what we're going for. Next, FG. So we've got F already at negative 2, negative 2. G's up here at negative 2, 8, giving us a distance of 10. Let's prove it. 8 minus negative 2 equals 10. Kaboom! All right, rapid fire this time. E, G. E all the way up to G. So we still have E at negative 2, negative 5, right where we left it last time. And G also on the negative 2, but this time we're going all the way up to 6, giving us a distance of 11. Because 6 minus negative 5 equals 11. All right, keep it up. GA. Right here, whoop, that one's going to be tiny. So G, still at negative 2, 6, a at negative 2, 8, giving us a teeny tiny little distance of just a 2. Uh-oh. Why don't I fix that? And we can prove it because 8 minus 6 equals 2. All right, 2 more, guys. FA. Boom, right there. So F, negative 2, negative 2, A, negative 2, 8, for that distance of 10, because 8 minus negative 2 equals 10. Are you ready for our last one? EA, E all the way up to A. So E, negative 2, negative 5, A, negative 2, 8, giving us a whole distance of 13. And our last proof, because 8 minus negative 5 equals 13. All right, after all that, you think you got it? I bet you do, and I want to point out one more time that when we're looking at horizontal lines like AB, then you're going to see an identical y-coordinate. Vertical lines, like all these, have identical x-coordinates. Good luck!